Good morning, students. I am M. Venkataya, Assistant Professor in the Department of Mechanical Engineering. Now I am going to teach the subject is thermal and hydro prime movers. So that is fourth unit. That is impact of jets and vanes. So this is a syllabus of fourth unit we already discussed in the previous classes. So once again I repeat it. That is impulse momentum equation. Impact of jet on stationary and moving vanes, flat and curved. And then after completion of that topic, then go for the pumps. That is the different types of pumps. That is centrifugal pump and reciprocating pump, and working principle of centrifugal pump as well as the reciprocating pump. Okay. Then today's class is how to explain about the impulse momentum equation, impact of jets on stationary and moving vanes, flat and curved problems. So in the previous classes I have discussed and explained the equation of impulse momentum equation, that is the stationary or curved plates. So that is the stationary of jet on stationary and moving vanes, flat and curved plates already discussed in the previous classes. Now I am going to explain about the problems. So what they given and what we have to find out. Okay. So see the problem, first problem. So find the force applied by the jet of water of a diameter 75 mm on a stationary flat plate. So they given the stationary flat plate. Okay, the jet strikes the plate normally with a velocity of 20 meter per second. So they given, first of all we have to read 2 or 3 times of the problem, because of when you read 3 or 4 times of the problem, you should understand the what they given the data and what we have to find out. So see the once again. So first see the problem. Find the forces applied by the jet of water. So we have to find the forces. Okay. So we want to find the forces applied by the jet of water of diameter 75 mm. So they given the diameter, that is the 75 mm on a stationary flat plate. So they given the stationary flat plate. The jet strikes the plate normally with a velocity of 20 meter per second. So here the velocity is given, that is a 20 meter per second. Okay, so what we have to find out here? The forces. So we know that the forces that is belongs to the previous classes. So that is the impact of jets, the momentum equation, that is the stationary. So stationary plate, already they given the stationary plate. We know that the formula. Okay, so we have to find the forces applied. That is forces applied means in the sense of x direction as well as the y direction. So here the fx equal to we have to find, and the fy we have to find. So first the given data is the diameter. So the diameter d equal to 75 mm as well as the velocity. So initial velocity or final velocity, finally they given the velocity, that is a 20 meter per second. Okay. So see the problem. First we have to solve this type of problem, that is the diameter. So the given the diameter, we have to see here. I will explain clearly here only. Okay, see. So diameter, what they given? D equal to 75 mm. So we have to convert the mm to the meters. So meters means that is 75 by 1000 equal to 0.075 meters. Is it clear? Then the area. So here they given the diameter. So that's why we have to find the area. Area in the sense of A equal to pi by 4 d square. Why we are writing the pi by 4 d square? So because of the vanes, that is the impact of jets, curved plate. or a stationary plate we are given. So we have to find the area, that is the stationary plate area is A equal to pi by 4 d square. So they given already d value, then we have to solve here. So pi by 4, d means 0.075 meters. So pi by 4 d square. Okay, then the here we have to see here the value is 4 point. We have to calculate in the calc. So then we want to finally we get the value of 4.417 into 10 to the power of minus 3 meter square. Okay, that is the area of the stationary plate. Area of the stationary plate. Then what they given? Velocity given. Velocity is 20 meter per second. Okay, so we have to find what we have to find here is that is Fx, means x direction. We have to find the forces as well as the Fy values. Okay, so we want to find Fx, how much value, and Fy. We want to find Fx as well as the Fy. So that here, that is the Fx. What is the formula for that one? The forces in x direction, rho a v square. So in the previous classes I already tell to you. Okay, that is the force in x direction of a stationary plate formula. Okay, then we have to solve here, that is Fx equal to rho, means we know that the rho means density of water. So that is the constant value 1000. Okay, that is 1000 into area. We are already find it, that area 4.417 into 4.417 into 10 to the power of minus 3 into velocity. So velocity, what they given? 20 meter per second. So rho a v square. Then we have to find the value and we get the data of Fx equal to 1766.8 newtons. So forces in the units of newtons. So this is the Fx value. Then Fy value. So Fy, what is the formula for that one? Minus rho a v square. Okay, minus rho a v square. So minus rho a v square minus rho a v square, what they given? 17. What we get the value? That value is 1076.8 Newton. That is the y direction. We have to take the negative because of the formula is belongs to negative. Okay, this is the process of impact of jets problem. Okay, then first I want to explain again because of what they given and what we have to find. Once again, see the problem. So that is the first we have to find the forces applied by the jet of water. So we know that the water constant values. That water is a density. The water has some density. That value is 1000. So that is the constant value for water density of diameter 75 mm. So they given the diameter 75 mm. They given on a stationary plate. The jet strikes the plate normally with a velocity of 20 meters per second. So velocity they given. So we know that the what we have to find here is find the forces applied. So here two forces is there. One is the x direction, that is the Fx, and the y direction, that is the Fy. Okay, we have to find the Fx value and Fy value. We know that the formula because of we are already in the previous class. We have in the previous class we have the formulas also. Okay, that formula is Fx equal to rho a v square. Okay, and Fy minus rho a v square. We know that the rho value. Rho means density, that is 1000, and the A means area, pi by 4 d square, area. So area, we know that the area that is pi by 4 d square. Okay. Velocity, we know that the velocity already, the problem they given the velocity. Okay. Then we have to find the fx value as well as the fy value. Okay. See the. So they given the diameter, that is 75 mm. We have to convert the mm to the meters. That's why we have to write 75 by 1000. That is 0.075 meters. Okay. Then A value. A means we know that the area is stationary plate. That area is pi by 4 d square. So pi by 4 d square. Here pi by 4 d means what they given 0.075 meters. Okay. Then we have to substitute in this value from in this equation. Then we get the value of 4.417 into 10 to the power of minus 3 meters square. Okay. Then the velocity, that is the velocity already given 20 meters per second. Then we have to find the fx value. Fx means the force in x direction, that is rho a v square. Okay, so rho a v square means rho means density of the water. So the density of the water, that is a constant value, and a means area. We are already finding the area, that area and the density values as well as the velocity values we have to put in this equation. Then we get the value of forces in x direction. Okay, then the y direction. So forces in y direction, we know that the formula, that is minus rho a v square. So we have to substitute on that equation. Then we get the value of minus 1766.8 in newtons. So that is the force units we have to calculate it. This is the procedure. This is the procedure of the momentum equation of a stationary plate as well as the curved plate and the moving plate. Okay, this is the sequence of these formulas. And this is the second problem, that is the water is following through a pipe at the end of which is a nozzle is filtered. The diameter of the nozzle is they given the diameter. So diameter of the nozzle 100 mm and the head of water at the center of 100 mm. Okay, find the forces applied by the jet of water on a fixed vertical plate. The coefficient of velocity is given as 0.95. So first of all, we have to read 2 or 3 times. Why? Because when you read 2 or 3 times, then we get some data. That is what they given and what we have to find out. Okay. So once again, so first what they given here, the water is following through a pipe. Okay, at the end of which is a nozzle is fitted the diameter of the nozzle is diameter. They given the diameter. So here the diameter 100 mm. They given the diameter of 100 mm and the head of water at the center of the water at the center is 100 meters. Okay, 100 meters. Then find the forces applied by the jet of water on a fixed vertical plane. The coefficient of velocity is already given. The coefficient of velocity. So that is the 0.95. So we have to find the forces in x direction as well as the forces in y direction. Is it clear? So we have to find here forces in x direction Fx and forces in y direction. We know that the formulas. Then we have to substitute what they given, what we have to find out. Okay, so we have to see. So in this equation, first of all, see the problem solution. So that is they given diameter. That is the diameter D equal to 100 mm. We have to convert the mm to the meters. So then 0.1 meter. And the height, head, what they given? H equal to 100 meters. Okay, then the efficiency. So V actual and V theoretical velocity. So V actual and V theoretical is 0.95. Then the theoretical, we know that the formula. So velocity of theoretical square root of 2gh. Okay, square root of 2gh. Then we have to solve here. 2 into g means gravitational force, that is 9.81. And the height what they given? 100. Okay, we have to substitute in this values from this equation. Then we get the value of 44.29 meter per second. 44.29 meter per second. Okay, so that is the actual. We have to calculate the theoretical as well as the actual. We have to calculate it. That is velocity of actual. So they given 0.95 into 44.29 into 44.29. Okay, we have to substitute and calculate. Then we get the value of velocity of actual 42.07 meter per second. 42.07 meter per second. Okay, is it clear? Then go for the go for the area. So we know that the area of a stationary plate or curved plate, we know that the formula, that is a pi by 4 d square. Then the d value they given the 0.1. Already we gained that value. We gained that value. That is already problems. In problem they given the 0.1 mm or 100 mm. So that is convert into the mm to the meters. Then we get the value of 0.1 m. That is the diameter. Okay. So we have to take that value, that is area equal to pi by 4 d square. So pi by 4 d square means 0.1 whole square. Then we get the value of area, that is 7.85 into 10 to the power of minus 3 meter square. Okay. Then the direction of fx value. So fx value, we know that the formula, that is rho a v square. Rho a means rho is the density of the water. We know that density is 1000. And area we get the value 7.85 into 10 to the power of minus 3. And velocity and the velocity we get the value 42. That is we have to put the value is the actual velocity, that is 42.07 meter per second whole square. Then we get the value, that is 3893.59 newtons. Okay, as well as the forces in y direction. So the forces in y direction minus rho a v square. Then we have to see that value minus, we have to put the inside of the value. So that is Fy equal to minus 13,893.59 newtons. Okay, is it clear? This is the sequence of problem solving of impact of jets and vents. So momentum equation. So some of the problems we have to do that problems given the already material. So that problem is I have to read one thing. A jet of water of diameter 75 mm moving with a velocity of velocity. They given the velocity. So that velocity is 25 meter per second. So that is the velocity we given. Strikes a fixed plate in a such a way that the angle between jet and plate is 60 degrees. So angle they given the theta value. So 60 degrees. Find the forces exerted by the jet on the plate in the direction normal to the plate in the direction of the project of jet. Okay. So they given already a jet of water of diameter. So diameter they given the diameter, that is 75 mm. So we have to convert the 75 to the mm to the meters. So 0.75 by 1000. Then we get the 0.075 meters. Okay. I'm moving with the velocity. So velocity they given 25 meter per second. Okay. Then it strikes a fixed plate in a such a way that the angle between the jet and the plate is angle they given the theta equal to 60 degrees. Find the forces exerted by the jet on the plate in the direction normal to the plate in the direction of the jet. So we have to solve the forces in x direction. Forces in x direction we have to find, and the force in y direction. Okay, we have to find. This is the sequence of problem solving. And another one more problem is there. That is a jet of water of diameter. So that is the diameter already given. And moving with the velocity already given. Strikes a curved fixed symmetrical plate at the center. So here they given the curved fixed symmetrical plate at the center. Find the forces applied by the jet of water in the direction of jet. Okay, if the jet is detected through on angle of 120 degrees, theta value they given at the outlet of curved plate. Okay, so at the outlet of curved plate they given that value, theta value, that is theta equal to 120 degrees. Okay, so we have to solve. First we have to read that problem. So one more thing, a jet of water of diameter. So they given the diameter they given and the velocity given. Okay, we want to find the forces exerted by on the jet particular. Okay, so then we have to find the value of fx value and then the fy value. So we know that the formulas of fx and the fy I already explained in the previous slides. Okay, and today's class what I have discussed is the first thing is problems on impulse momentum equation, that is the curved or the moving and the fixed plate. Okay, next class I want to explain about the impact of jets, momentum equation of thermal efficiency of the jet as well as their problems. Okay, thank you.